Welcome to the Fresno City College Psychology Department's video tutorial on the correlational method of research. You might say that psychologists are obsessed with the phrase, correlation is not causation. Why do I say that? Well, a Google search of correlation does not equal causation gifts gets you shirts for adults, kids, and babies, including a bib, a coffee mug, travel mug, water bottle, and can holder, a tote bag, a fanny pack, and a hat. Having a barbecue, there's an apron and some paper plates. For your car, there's a keychain, floor mats, and a bumper sticker. For your electronics, there's a phone protector, a laptop sleeve, and a mouse pad. There's a clock and a watch. For your pets, there's a dog bed and a name tag. I actually found a few more things that I decided not to include, and I have no doubt that I stopped looking before I'd even located everything that is available to buy, with correlation is not equal to causation printed on it. So, before this video concludes, you should be wise to the correlation does not equal causation catchphrase. Let's review some basic information about the correlational method of research. For the correlational method, researchers do not manipulate any of the variables. They simply observe two variables in order to determine if changes in one are associated with changes in the other. Another way of saying correlated is associated. Variables may have no relationship at all. That is, they may not be correlated. And believe it or not, you can find merchandise depicting that too. Variables that are correlated may have a positive relationship or a negative relationship. This is referred to as the direction of the relationship. A positive direction is called a direct correlation. A negative direction is called an inverse correlation. Variables that are correlated may have a strong or a weak relationship. This is referred to as the strength or the magnitude of the relationship. This scatter graph shows data for all 50 of the United States from 2005 for two variables. Variable X is the percent of the population living below the poverty level. Variable Y is the percent without a complete high school education. The line of best fit indicates an upward trend. There is a positive correlation between the percent of population below poverty level and the percent of population without high school education. That is, low scores on variable X are likely to correspond with low scores on variable Y. Mid scores on variable X are likely to correspond with mid scores on variable Y, and high scores on variable X are likely to correspond with high scores on variable Y. These data reveal an interesting relationship between these two variables, but leave us with questions about the cause-effect relationship between them. Does high school dropout cause poverty? This might seem like a reasonable conclusion. We know that higher-paying jobs tend to require more education, and it can be difficult to even find a job without a high school diploma. But could it be the other way around? Does poverty cause high school dropout? It is difficult for teens who live in poverty to get through school. Some of them have to quit school and find jobs just to survive. It might not be one or the other is the cause. The answer to both questions might be yes. We have to wonder, is the relationship bidirectional? That is, incomplete high school education causes poverty, and poverty causes people to not complete high school. A vicious cycle that plagues generations. Or is there a third variable responsible for this association? Is there a variable Z that is the cause of both poverty and high school dropout? A few years ago, I calculated the correlation for absences and grades. This slide shows the scatter graph that was generated from actual data from one of my class sections. You can see the line of best fit is showing a downward slope, indicating a negative correlation. Remember that each dot represents the number of absences and the grade for each individual student. For example, Greg was absent 17 out of 48 class sessions and earned an F, while Sally was absent only 3 out of 48 class sessions and earned an A. The correlation for these data is negative 0.688, which is a moderately high correlation. correlation. Let's return to the question of causality. Is there a causal relationship between absences and grades? Can we conclude from these data that being absent from class causes a lower grade in the class? That might seem like a logical and accurate conclusion, but we need to stop, think, and question this conclusion. It is also possible that students who earn higher grades are less likely to be absent. We have to ask ourselves, would the A and B earning students have earned A's and B's anyway? If so, why? Perhaps there is a third variable that better accounts for the relationship between absences and grades. Maybe the students who attend class are also more likely to engage in class preparation activities. Maybe the students that earned A's and B's not only did not miss class, but they completed the reading and the homework for the class. This might help to explain why there are students who did not miss class and earned C's, D's, or F's. Maybe they came to class but did not complete the reading and the homework. We would need to conduct some survey research to investigate this possibility. Another possibility is that the students who earned A's and B's have more academic confidence. Yet another possibility is that the students who earned A's and B's are less likely than the students who earned C's, D's, and F's to have life stressors. What causes students to do well and earn A's and B's? By examining the correlational data, we can uncover some possibilities that may allow educators to maximize student potential. Education relies heavily on correlation because true experiments are often just not possible. For example, we cannot systematically manipulate the life stress of students. Therefore, we cannot manipulate life stress as an independent variable. We can only measure it in a correlational study. Causation means that one thing will cause the other thing. Just because two things are correlated doesn't necessarily mean that there is a causal relationship between the two variables. Correlation does not equal causation. As I said in the introduction to this video, psychologists are a bit obsessed with this catchphrase, correlation does not equal causation. If we let our guard down and allow ourselves to jump to a cause-effect conclusion based on correlational data, we run the risk of identifying the wrong variables as causal, and therefore stifling the efforts to identify the actual causal variables. In the late 1940s, U.S. citizens were warned to cut back on their consumption of ice cream and other sugary treats because of the correlation between ice cream sales and polio. Surely there must have been something about the ice cream that was contributing to the spike in polio, right? Of course, sugar consumption had nothing to do with the polio outbreaks. Polio was showing a seasonal pattern. So, people were decreasing their consumption of ice cream because they thought it was protecting them and their children from getting polio. Sometimes two variables show a strong correlation and have nothing to do with each other in any meaningful way at all. Take this strong correlation between divorce rate in Maine and the per capita consumption of margarine. Imagine jumping to the conclusion that eating more margarine will prevent divorce. The primary disadvantage of the correlational method is that correlations do not identify the causes of behavior. I really like the way that Hank Green of Crash Course Psychology sums up the correlational method. He says, correlations predict the possibility of cause and effect relationships, but they cannot prove them. I like this because it succinctly describes both the disadvantage and the advantage of the correlational method. While it is true that correlation does not equal causation, correlations do predict the possibility of causation. We need to be sure not to criticize the correlational method so much that we forget about its major advantages. This method clearly broadens the scope of what researchers can study. This means that as long as the variables can be measured, they can be studied. Researchers do not need to be worried about the ethics of manipulating an independent variable because there isn't one. They are simply examining the data that can be captured in some way. Many of the questions that psychologists are interested in answering do not allow for true experiment. For example, why do people kill themselves? What impact does domestic violence have on children? And does early use of marijuana negatively affect development in adolescence? These questions can be studied only through the examination of correlational data. Other advantages are that the correlational method offers some clues to understanding causes, increases understanding of relationships between variables or events, and can identify groups of people at risk for physical or behavioral problems. The possible benefits of caffeine are in the news every so often. Here's a chart showing the negative correlation between vision impairment due to cataract and caffeine consumption. Remember, negative doesn't mean bad. Negative means that high scores on one variable predict low scores on the other variable. In this case, researchers found that lots of cataract-related vision impairment corresponded with low consumption of caffeine, and low levels of cataract-related vision impairment corresponded with higher consumption of caffeine. Similar correlations have been found with Parkinson's disease and other medical issues. So, shall we all go out and start consuming more caffeine? Well, researchers are still working on identifying a causal link between caffeine and health benefits, primarily by using animal models. The human correlational data provides the basis for further experimental investigations. This concludes the Fresno City College Psychology Department's video tutorial on the correlational method of research. Now you can join the Correlation Does Not Equal Causation Club.